Hi everyone, this is the first part, so day one of the lesson 2. It's literally about literal equations, and tomorrow, the next lesson, day 2, will be more on literal equations. Today we're going to be focusing on these green targets right here. So rewriting linear equations in different forms, and also analyze the structure of different forms of linear equations. Okay, so if you notice right here, this is not the do now. Oh, this is page M291, 91 of volume 1, your book. And if you notice right here, this is definitely not that do now, the warm up. I changed it because this would be more pertinent to what we're doing right now. So if you notice this graph right here, I ask for y-intercept, x-intercept, slope, and the equation. And if you notice, the y-intercept is what? The point at which this line right here intersects the y-axis, which is right here at, as you can see, 0, 1. And if you remember, the x comes first and then the y. So make sure you always write the x first and then the y. And then the x-intercept right here is going to be where that red line crosses the x-axis, right? And so that's going to be right here at -2. And so we're going to write that as a point. So it's going to be -2, 0. And to always to indicate points, you have to put them in parentheses, or else they're just numbers. And the slope is how tilted something is, right? Is it really steep? Is it it's just a slight slope, right? Just like skiing, or if you're like skateboarding, it's a slight slope. But if you look at this right here, this is one. So we're the way we've decided to do that ratio of how high does it go versus how across does it go. I don't know if those are real terms, but that's going to be the rise, right? That's one unit over 2 units. Okay, just like that. Or maybe for you, it's like this. I don't know which way. But yeah, so up 1 to the right 2. So we show that by doing this fraction, so 1 over 2. Okay, so the 1 represents how far the y goes up compared to how far the x goes across. All right, so 1 over 2. Another way we can indicate that, you may see this in the future, is change of y over change of x. So that's how much the y is changing over how much the x is changing. You may have heard it before, maybe in middle school, as rise over run. Same idea. Rise over the run. Rise, run. All right, and then the equation. Most people are familiar with, or maybe you're not, or you should have seen maybe in middle school, or maybe in a previous Algebra 1 class, y equals mx plus b. This is what we call the slope-intercept form. So always that first, the number in front of the x, regardless of where the x is located, the number in front of it is called the slope. Okay, that indicates how much it's tilting. And then the b is always our y-intercept. Okay, so the number that's by itself is the y-intercept. So we do happen to know both of these things, so we just plug those in. So we know the slope is 1/2, so we plug in the y is equal to 1/2 x, and the y-intercept is just 1. So that's where we're going to 1. We're not going to ever include the x part of that, just because this the 0 and that's the x part of it. And this is, we're just talking about the y value, because the x will always be 0 for y-intercept, just like the y will always be 0 for the x-intercept. A little tip there. All right, so we're going to skip this page and we're going to go to the next page, which is on 93. Equations in different forms. So there are 3 forms that we're going to see. The first one we already saw, which was a slope-intercept form. And remember, we're going to list these 3 things: slope, y-intercept, and x-intercept. And the reason why it's called the slope-intercept form is because why? We are given the slope and the y-intercept, right? So that's why. So that's the slope. And then, so again, we can just by looking at the equation, we can identify already what it is. So the slope is -2/3, and then the y-intercept is the 4. The x-intercept is the one that we don't really know. But let me just, if you note on the right-hand side here, I picked a couple of different points on the x-axis. And if you notice, all of them end in a 0, right? So it's -4, 0, -2, 0, 3, 0, 5, 0, right? And so which means that any point on the x-axis is where y is equal to 0. And why is that? Because it's not going up and down, up or down from the 0 for the y, right? So we know that if it's the x-intercept, the y will always be 0, always. 100% without fail, right? And so we know that the y is 0. So we know the equation, so we're just going to plug it in. I used a lot of so's in there. You don't know how many, but it seems like a lot. Now I'm trying not to say it. So here's 0 is equal to -2/3 x plus 4. We just plugged in 0 for y, right? Because we know that y is equal to 0. We just want to know what x is. We just plug it in, right? And then, so now we're just solving for x, just like how we've been doing, right? And so again, we're going to subtract 4 on both sides. And then to get rid of this -2/3, we're going to just multiply by the reciprocal. Okay, so the quickest way to get rid of a fraction is to just multiply it by its reciprocal. Another way you could do that is take it in 2 parts. So you would multiply both sides by 3, right? Get rid of 3 on the bottom and get rid of fractions, which we've done before. And then we're going to have a -2x, right? So then just divide by -2. But this is just putting those 2 steps in one. So we're going to multiply by -3 and divide by 2 all at the same time, right? So there we go. And if we multiply the left-hand side, the -3 times -4 is +12. 2 times 1, remember that's like a over 1, is just 2. And so our x is going to equal 6. What? So that's why we put this number right up there. So our x-intercept is at 6. And again, if we check our Desmos, it does show us those aspects of it. Let me pull up Desmos really quick. So as you guys can see here, I pulled up Desmos and notice right here again, this is at 4 and the x-intercept is at 6, which is what we said. The slope, we said was, I don't remember something, -2/3. So we're gonna go, so if you notice right here, so we're gonna go up 1, 2, and then 3 to the left. Oh, 1, 2, 3, it's right there. So up 2 and then to the left 3. Honestly, you can go, why do we go left? Because one of them has to be negative, right? So instead of going up 2, I could just go down 2, right? So that's my negative part. And then I go to the right 3, 1, 2, 3. And notice I still end up on a point on the line. Okay, so anywhere on here, you find a point, go up 2 and to the left 3, or down 2 and to the right 3, you're going to end up on the line again. Okay, you can't get away. All right, so there, that is what we were looking for. Okay, so now we're going to go to the next one. Consider this equation right here. Y is equal to 4 times x minus 2. And you will notice right here that our slope and intercept is a little bit different. Notice the 4, yes, still the slope. But we're going to just change this to slope intercept form because that tells us a bit more information. So that's what we're going to do. Excuse me. So we're going to plug in. So we're just going to use distributive. We're just going to distribute. And then we're going to say, so we get y is equal to 4x minus 8. And again, we know that the minus 8 is our y-intercept. And our slope is 4. So notice still the same 4. We still don't know our x-intercept. So again, remember, we're going to plug in 0. I like to use the original equation. If you want to use the other one, you can. It's just good practice to use the original equation, right? So that's what we did. So instead of y, we're going to put in 0 and then copy down the rest. So 4 times x minus 2. Excuse me. So here you can distribute as well. Or I noticed that since the left-hand side is 0, which means that anything, it's going to be pretty easy. So 4 divided by 4, because we're going to get rid of this 4. I'm not going to distribute it. I'm just going to get rid of it right here. So divide that by 4 on both sides. And what's 0 divided by 4? Still 0. So you see how it's much easier. And then all we have left, the 4's cancel out. So all we have left is x minus 2. And then at this point, we're just going to just add 2 to both sides to get rid of that minus 2. Because minus 2 plus 2 is 0. And then all we have left is just the x, and then 0 plus 2, which is 2. So we know that x is equal to 2. So that's where we get the x-intercept right there. All right. In general, whatever equation you have, if you change it to slope-intercept form, that will give you the most information. All right. Standard form, We learn that a little bit later, but standard form gives you the least amount of information, right? It gives you no slope. It does not give you the y-intercept or the x-intercept. It gives you none of that, but you'll see often a standard form. So, but we know what to do. We know maybe we know how to change the standard or the slope-intercept form, right? So again, first things first, we want to get the y by itself, right? Because it's y equals mx plus b, right? So we're going to get rid of the whole 3x, right? So we're going to subtract 3x on both sides. And then we're going to bring down negative 2y. The negative 2y, remember I told you minus negative, we're going to consider that to be the same. And then if you notice right here, negative 3x and 8 minus 8, we can't, they're not like terms. So we just literally write them separately. So negative 3x plus 8. The reason why I wrote the x one first is because, you know, y equals mx, the x comes first as well. So we're just going to do that. Last part, we're going to divide both sides by negative 2 because negative 2 is multiplying with y, not adding or subtracting. It's multiplying. So we're divided by negative 2. And so we get y is equal to, I'm going to just distribute this negative 2 to both of them. So it's negative 3 divided by negative 2, which is 3 halves. And then x. And then 8 divided by negative 2, which is negative 4 or minus 4. All right. And so y is equal to 3 halves x minus 4. That is the slope-intercept form. So now we know the slope and the y-intercept. So again, the slope is 3 halves, and then the y-intercept is 0, negative 4. Please get used to writing them as a point. It will make your life a little bit easier. And it will help you to remember, oh yeah, x is 0, right? Here for the x-intercept, oh yeah, the y is 0. Okay, that helps you with that. And if you notice right here on the bottom, we're going to use this original form right here, so we don't have to deal with fractions because, you know, slope-intercept form has fractions. And as I said before, just use the original form. It's the best way to do it, just in case there are errors, right? And we're plugging in 0 in for y. So that is, let me find a pink. There we go. The 0 right here. That's this y right here. All right. So 0 in for y. And then we know that 2 times 0 is 0. Yay, makes it really easy. So all we have left is 3x is equal to 8. And then divide both sides by 8. Not 8, 3. Right? Divide both sides by 3 and x is equal to 8/3. And that would be our x-intercept. All right. So it's the same process every time. Some of you guys may wonder, well, what about the y-intercept? If we could plug in the y is equal to 0 for the x-intercept, I mean, you can actually do it for the y-intercept as well. Like, what if you didn't remember that? Well, let's plug it in. If you put in 0, 3, oops, not highlighter. Sorry. So if we're going to plug in 3x minus, oops, 2y is equal to 8. And we're going to plug in 0 in for x. So it's going to be 3 times 0 minus 2y is equal to 8. So we know 3 times 0 is 0. So we just have negative 2y is equal to 8. And how do we get rid of the negative 2? I certainly hope you said divide by negative 2, right? And then we are going to get y is equal to 8 divided by negative 2, which is negative 4. If you notice right there, what? Right? So that's why it is the y-intercept. And honestly, if you look at the y-intercept, you plug in 0 for x. What's 3 halves times 0? 0. What's 0 minus 4? Negative 4. That's why this number is always the y-intercept. For that reason. That's my little bonus for you because I didn't say that in class. I should have. I will probably next time. All right. Hopefully, if I remember. But anyways, so here we have these 3 forms. I should technically just not put this in there. It is similar to the point slope form, but it's actually not the point slope form. There is another form called point slope form, but it's not often used. But I like to use it personally just because it makes writing equations so much simpler. Like, so all you need is a point and a point on the line and a slope. That's it. Super easy, but kind of hard to remember the formula sometimes. So, all right. So here, what we know as y equals mx plus b, which is the slope-intercept form, the general form, AKA, right? Same thing, is y is equal to ax plus b. So instead of m, it's a, but that's fine. They just go in alphabetical order like that. Factored form and then standard form. You won't see factored form very often, but they're kind of prepping you. This book is prepping you for like quadratics and things like that, where there is a factored form. It's an actual thing. So here, Is it useful? Kind of, not really. We don't see it too often. But yeah, you'll see often, even for, what is it called? Word problems, you'll see a lot of them in standard form or slope-intercept form, one of the two, right? So get used to those two. And we had gone back up here and talked about, if you notice the ones in maroon or purple, these were the different forms. So the first one is general form, i.e. slope-intercept form. The second one was factored form, i.e. we don't really need to know it that much, but still it's good to know. And third one is standard form, which is, there's no other word for it. It's just called standard form. That's what we call them in general. All right. So there we go. And we will finish the rest of it next time. See you later. Bye.